Hello students, before we get into today's class, I wish to recall what we learned in the previous class. So we are learning about polynomials, and in the last class we have learned what is the relationship between the zeros of the polynomial and the coefficients of the given polynomial, right? So we learned for a quadratic polynomial, it's if its zeros are denoted by alpha and beta, then sum of zeros alpha plus beta, which is nothing but minus b by a, and product of the zeros alpha beta is nothing but c by a, where a is the coefficient of x square, b is the coefficient of x, and c is the constant term. And also we have seen how to frame a quadratic polynomial using the given zeros, which is nothing but x square minus sum of the roots into x plus product of the roots. If you know the zeros of the polynomial, you can very well frame the quadratic polynomial. If you know the polynomial, you can very well find the zeros, right? This is what we learnt in yesterday's class, and we have solved 2 problems, and we will see few more problems in the same exercise. So exercise 2.2, in the first question we have fourth subdivision. The question is 4u square plus 8u. If you see this question, 4u square plus 8u, this looks somewhat different from the previous questions. In what way it is different? It doesn't have the constant term, right? So what is the procedure to solve this problem? The question is to find the zeros and also to verify the relationship between the zeros and its coefficients, right? So how you will find the zeros? I told you first factorize the quadratic polynomial. Now how we will factorize the quadratic polynomial? Using splitting the middle term, right? But here we don't have the constant term, so you should not find difficult to solve it. It can be easily solved by taking the common terms out. We have learnt all these kinds of methods in the previous classes, 8th and 9th standard, right? So take the common term out. Which is common? 4u is common. So what is left out? U plus, I have taken 4u as common, so I have 2. So 4u into u plus 2, right? Then why I have equated to 0? Because what, by the definition of the 0 of the polynomial, which says that the point at which the value of the entire polynomial turns 0, then that particular point is called the 0 of the polynomial, right? So we need to equate it to 0. Now equate it to 0, what will happen? This is product of 2 terms. This how only we will arrive even in the splitting the middle term. Yes, we will at last we will arrive at product of 2 terms, then we will equate both the terms to 0 to find out the value of the variable. Now the same way we are going to equate 4u to 0, so u is 0. On the other hand, u plus 2 equal to 0, so u equal to minus 2. So we arrived at 2 zeros of the polynomial. Still anyone is having doubt? If you have doubt, you just contact me, right? Hope you understood. Now alpha is 0 and beta is minus 2. Now as usual, the remaining procedure is same. We need to verify the relationship between the zeros and the coefficients. Now what is the relationship? Sum of the zeros, alpha plus beta. What is alpha plus beta? 0 plus minus 2. 0 plus minus 2 is minus 2, right? And what is alpha beta? Alpha beta is 0 into minus 2, 0 into anything is 0, right? Now by definition, what is alpha plus beta? Alpha plus beta is minus b by a. Now before finding out minus b by a, first we will state what is a, b, c. A is nothing but the coefficient of the x square. Here the variable is u, therefore u square. What is the coefficient of u square? 4. B is coefficient of u, which is nothing but 8. And c is constant term. We don't have constant term in the polynomial, so the value for c is 0, right? Now just substitute minus b by a, which is equals to minus, the value of b is 8 and the value of a is 4. So if you cancel, you will get minus 2. Yes, we got alpha plus beta is same as minus b by a. Next, alpha beta by definition is c by a. So the value of c is 0. By the value of a is 4. 0 divided by anything is nothing but 0 only. So we got alpha beta is equals to c by a. Hence the relationship between the zeros and the coefficients of the polynomial is verified. Yes. We have another question, t square minus 15. How you will solve this problem? Here we don't have the middle term, but we have the constant term. So how you will do it? Here we cannot go with splitting the middle term. We cannot take the common term out. So directly equate it to 0. So what will happen? T square is equals to 15. So t equal to square root of 15, and whenever we have square root we will have plus or minus, right? So therefore the two roots are, or the two zeros are, plus root 15 and minus root 15. Plus root 15 and minus root 15. Now go ahead with the same procedure. Find what is alpha plus beta plus root 15 plus of minus root 15. Plus into minus is minus. So plus root 15 minus root 15 is 0. Then find what is alpha beta. Root 15 into minus root 15. Plus into minus is minus. Root 15 into root 15 is nothing but 15. So minus 15. Now let us see what is minus b by a. And before writing minus b by a, we will find out the values of a, b, c from the question. A is nothing but the coefficient of t square, so which is 1. B is nothing but the coefficient of t. We don't have t term at all in the polynomial, so the value for b is 0. C is constant term. Constant term is minus 15. Take along with the sign. So minus b by a. So 0 by 1, which is nothing but 0. So alpha plus beta minus b by a both are 0. Then alpha beta is c by a, which is equals to minus 15 by 1, which is nothing but minus 15. So we arrived at the same answer. Alpha beta is same as c by a. Hope you understood, right? Now we will do one more problem in the second heading, which I felt that you people will feel difficult since it has square root. The question is to frame the quadratic polynomial where the first value is sum of the zeros and the second value is the product of the zeros. So alpha plus beta is root 2 and alpha beta is 1 by 3. Now we need to frame the quadratic polynomial. What is a quadratic polynomial? X square minus sum of the roots into x plus product of the roots. So this implies x square minus sum of the roots is root 2x plus product of the roots is 1 by 3. Even if you stop, the answer with this is also correct. It is not necessary, you should take LCM and all. You can stop with this, right? So the quadratic polynomial, the required quadratic polynomial is x square minus root 2x plus 1 by 3. So now we are going to see a cubic polynomial. The same concept we can extend to a cubic polynomial even. So what is the standard form of writing a cubic polynomial? Ax cube plus bx square plus cx plus d. So now so far we represented two zeros as alpha and beta. Now we are going to extend it with the third zero saying gamma. So alpha plus beta plus gamma is minus b by a. Alpha beta plus beta gamma plus gamma alpha is equals to c by a. Alpha beta gamma is minus d by a. So what is a? Coefficient of x cube, b is coefficient of x square, c is coefficient of x and d is the constant term. Now using these relationships, how we can frame the cubic polynomial? X cube minus sum of the roots into x square plus sum of the roots taken two roots at the time, which means alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma, which is alternative plus and minus you should have. For the quadratic polynomial, we had square term, minus and plus. With that we stopped. When we have cubic polynomial, we will have another term. So you should have alternative plus and minus. Minus plus minus. X cube, x square, x constant term. Right? So using this also we can solve the problems. If a question is given in cubic polynomial, we should use these relationships to solve. These type of problems are there in the optional exercise. We will check out later. Right? Now we are going to see division algorithm for polynomials. So before getting into polynomials, we know what is a general division algorithm. What is a general division algorithm? If you divide a number by another number, dividend is equals to divisor into the quotient plus the remainder, right? For example, if I am going to divide 25 by 2, say this 25 is my dividend and 2 is my divisor. If I divide 25 by 2, what I will get? 2 12s are 24. I am doing it directly, so I got 1 as my remainder, right? So dividend is equals to divisor into the quotient plus the remainder. So what is my dividend? 25. How I can obtain my 25? By multiplying the divisor into the quotient. So 2 12s are 24 plus the remainder. 2 12s are 24 plus 1, we will get 25, which is nothing but the dividend. So this is the general division algorithm which stands good, which holds good for natural numbers, right? Now we are going to extend this division algorithm for polynomials even. This stands good for polynomials also. Similarly, if p of x and g of x are two polynomials with g of x is not equal to 0, then p of x is equals to, always the divisor should not be 0, right? We cannot divide a number by 0. So that's why they have mentioned g of x is not equal to 0. Now p of x is equals to g of x into q of x plus r of x. Here they denoted the quotient polynomial as q of x and the remainder polynomial as r of x with a condition where r of x is equals to 0. Remainder can be 0, right? Remainder can be 0. If it is exactly divisible, then we will get the remainder as 0. Or degree of r of x should be less than the degree of g of x. G of x is nothing but the divisor. So either the remainder should be 0 or the remainder should be less than the divisor. Obviously when we are dividing, we won't get a remainder more than the divisor, right? We will always get a number less than the divisor. The same way when we are talking about polynomials, we will say its degree. So the degree of the remainder should not be more than the degree of the divisor. Either the remainder should be 0 or the degree of the remainder should be less than the degree of the divisor polynomial. So p of x is equals to g of x into q of x plus r of x. Q of x is quotient polynomial, r of x is remainder polynomial, g of x is divisor polynomial and p of x is dividend polynomial. Let us see this through an example. So let us solve the first problem in exercise 2.3. They have given you what is p of x, g of x. They asked you to find q of x and r of x. In the sense dividend and divisor are given, they asked you to find the quotient and the remainder. Let us see how we can divide one polynomial by another polynomial. So x square minus 2. We are going to divide the polynomial x cube minus 3x square plus 5x minus 3 by x square minus 2. So this is similar to our normal division only. So what is our first aim? We should make the remainder as 0. We will take term by term, right? So first we are going to take the first term x cube and in the divisor the first term is x square. Our aim is to make the remainder 0. So we should get a term here in such a way, while subtracting we should get the answer as 0. So here it is x square. So by which term if you multiply you will get the term x cube? Only if you multiply by x, right? So x into x square only will give you x cube. So x into x square is x cube. Suppose if you are finding difficult to think logically like this, you can divide and check. So take the first term of your dividend and divide it by the first term of your divisor. What is the first term here? X cube divided by the first term of the divisor, which is x square. So x square will get cancelled. So we got x. So this will be the first term of your quotient, right? This will be the first term of your quotient x. Now start multiply this first term with each and every term of the divisor. So x into x square is x cube, plus into minus is minus, but we are going to get 2 into x as 2x term. But where is x term here? Here. So you after multiplying you should write it here only. So minus 2x. We don't have x square term, so replace there by 0. Now in normal division what we will do after writing the values, we will subtract, right? So the same way here we are going to subtract. How we can subtract two polynomials? By changing the sign of the second polynomial. This and all we have learnt in the previous classes. So change the sign. So plus x cube minus x cube will get cancelled. Minus 3x square minus 0 is nothing but minus 3x square. Now plus change the sign only, you should take it into account. Both are plus, so add the coefficients. 5 plus 2 is 7. So plus 7x. Right? So what we did so far, the first procedure is take the first term of your dividend and divide it by the first term of your divisor. X cube divided by x square, we got x. So this x is the first term of your quotient. Now multiply each and every term of your divisor with the first term of the quotient. X into x square is x cube, minus 2 along with the sign only you should multiply. Minus 2 into x is minus 2x. Since it's x term, we have written under the x term. We don't have x square term, so we have replaced it with 0. After applying the values, we need to subtract these two polynomials. How we can subtract the polynomials? By changing the sign of the second polynomial. So after changing the sign, these two will get cancelled. Minus 3 minus 0 is minus 3 and plus 5 plus 2 is plus 7x. Now bring down the last term, which is minus 3. Again the procedure is same. Take the first term of this expression and divide it by the first term of the divisor. First term of the expression is minus 3x square. Along with the sign only you should take. First term of the divisor is x square. So what will happen? We got minus 3. So the next term of the quotient is minus 3. Now keep on multiply minus 3 with each and every term of the divisor. So minus 3 into x square is minus 3x square. Minus 3 into minus 2 is minus into minus, it will become plus. 3 2s are 6. So it's a constant term. So write here plus 6. We don't have x term, so replace it with 0. Again the procedure is change the sign of the second polynomial to subtract. So minus 3x square plus 3x square will get cancelled. Plus 7 minus 0 is 7x. Minus 3 minus 6 is minus 9. That's all. So this is what our reminder. Why we stopped the problem here? Because we don't have any other term to bring down, right? So with this we have stopped the problem. So this is your r of x reminder and this is your q of x, right? If you want, we can check the answer using division algorithm. What does the division algorithm says? If you multiply the divisor with the quotient and if you add the remainder, you should get the dividend, right? So let us check whether it is true or not. Now here g of x is x square minus 2, q of x is x minus 3, r of x is 7x minus 9. So let us first multiply g of x into q of x. So x square minus 2 into x minus 3. Term by term you multiply. X into x square is x cube. X into minus 2 is minus 2x. Minus 3 into x square is minus 3x square. Minus into minus, it will become plus. 3 2s are 6. Right? X cube, x square, then constant term. Now with this we don't have any similar terms here, so we don't have any like terms here, so we don't want to add. With this we need to add the remainder. What is our remainder? 7x minus 9. Sorry. So if you add, what we will get? X cube term. We have only one x cube term, and x term if you see plus 7x minus 2x, it will become plus 5x. Then x square is, we have only one term, plus 6 minus 9 is minus 3. Let us rearrange it. X cube minus 3x square plus 5x minus 3. See exactly the same p of x which is given in the question. So we arrived at p of x. Thus the division algorithm holds good for the polynomials even. But in the exercise question they didn't ask you to verify and all. They just asked you to find out the quotient and the remainder. For our understanding sake, I just explained and we just checked whether are we getting the dividend or not. Like this we can check whether the problem which we did is correct or wrong. We arrived at the same polynomial, therefore what we did is correct. But it is not necessary, you don't want to waste your time by checking your answers. Just they asked you to find the quotient and the remainder. So this is what the procedure. So I want to repeat what we did. First write the dividend and divisor, divide the first term of the dividend by the first term of the divisor. The answer what you are getting will be the first term of your quotient, and keep multiplying the first term of the quotient with each and every term of the divisor. And after writing it, while writing, write the like terms together. Then you need to subtract it. How you will subtract? By changing the sign of the second polynomial. After obtaining the second expression, bring down the next term of the dividend and then repeat the same procedure. Divide the first term of the expression by the first term of the divisor. What you get will be the second term of your quotient. Then keep multiplying each and every term of the divisor with the second term of the quotient. You will get the second expression. Sorry. And then subtract by changing the sign of the second expression, and what answer are you getting will be the remainder. Where you need to stop the problem, where you don't have any more terms in your dividend, there you need to stop the problem, right? Hope you understood. The next two problems in the exercise in the first question is of same kind. Hope you can try. Okay, let us move on to the second question. If you see the second question, check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. What do you mean by the word factor? When you come across the numbers, when we will call a number is a factor of the other, if it divides the number exactly. What is meant by dividing exactly? If it leaves the remainder 0. For example, 5 is a factor of 25, because if you divide the number 25 by 5, you will get the remainder as 0. Therefore, 5 is a factor of 25. So, if a number divides another number exactly without leaving any remainder, then it is called a factor. So, the same meaning holds good in polynomial even. So, if a polynomial divides another polynomial with leaving the remainder as 0 or without leaving any remainder, is called a factor. So, in the second problem, what they asked you to check is, they asked you to check whether the first polynomial is the factor of the second polynomial. In the sense, the first polynomial given are divisors and the second polynomial given are dividends. So, start dividing and check what remainder are you arriving at. If you arrive at the remainder 0, then the first polynomial is a factor of the second polynomial. If you arrive at the remainder other than 0, then the first polynomial is not a divisor of the second polynomial. So, you can try these problems even. So, today's class homework is exercise 2.3, question number 1, second subdivision, third subdivision, and all the 3 subdivisions in the second question. Only if you keep practicing more problems, you will be familiar with the concepts. Simply I am doing, and if you are listening, then it won't be a practice at all. So, I want you to do by yourself, and if you have any doubts, you can contact me through WhatsApp, right? At any time you can contact me through WhatsApp. Simply don't watch the way I am doing or copying down in the notes. Start practicing yourself. Don't think ma'am is giving too many problems as homework and she is not doing any problem, right? So, start practice these problems. I have done one problem for you. So, do the remaining 5 problems by your own. Then only you will be familiarized with the concept, right? So, today's homework is exercise 2.3, first problem, second subdivision, third, and second question fully. And we will see the remaining things in the next class. And as I told you earlier, every Saturday you will be writing a small test. So, tomorrow you will be writing a test based on the topics which we covered so far in polynomials. It may be for 10 or 15 or 20 marks, right? So, do practice till division algorithm. You will be writing a test. I will be posting the question paper in the group, and I will give the proper instructions in the group. After an hour, you should post the answers in the group itself. Okay? If you have any doubts, contact me. Thank you, students.